Hello everyone, welcome to the last section in chapter 11, 11.6, Systems of Nonlinear Equations. I do still plan on doing the tests in the order that we were originally planning when we were in class. We're going to do the chapter 11 test on the 15th, and we should be able to get prepared and do this chapter 12 test on the 29th. This stuff is not too bad, honestly. Arithmetic sequences and geometric sequences are pretty quick. Actually, I'm going to take out 12.4. We won't do math induction. And then we'll do 12.5 binomial theorem. So we'll have those due and then do your chapter 12 test, because people tend to do well on that test, so I don't want to cut it. And then you'll have your final exam on the 6th. Thanks for sticking with me through all this. All right, so 11.6 is systems of nonlinear equations, and you actually did a section like this in college algebra, except these are a little bit harder, I'd say, but you're not going to use matrices for these. They're just they're in this chapter because they are still systems, but it's not, you can't use matrices for these. So you're just going to have to do them the same way we did in 11.1, where you just get rid of variables and figure out what they could be. Okay, so for number 16, we have x squared plus y squared equals 10. And then we have y equals x plus 2. So I picked this one to be first because you can draw an accurate graph of it, or fairly accurate. X squared plus y squared equaling 10. That's a circle with a center at 0, 0. And then the radius of the circle would be the square root of 10, which that's where we can't be super accurate, but the square root of 10 is 3.16. So if I go out 3.16 in every direction from 0, I can graph the circle. And then we have a line, y equals x plus 2. So that would start at 2, slope of up 1 over 1, and what's happening when we find our answers, we're finding the intersection of two graphs. Well, this one has two intersections. It has one there and one here. So we're going to have two answers. You're not going to draw the graph every time or anything like that, but just keep in mind that you could have more than one answer for any of these because of the squareds and stuff like that. When you just have two lines, you could have, infinite if they're on top of each other, but when they intersect like this, you would just have one if there were two lines. Okay, so this one, the best way to do it is honestly substitution, because we have y equals x plus 2. I mean, actually, you couldn't do elimination if you wanted to, so you have to do substitution. So we know y equals x plus 2, so I'm going to take that circle formula, the x squared plus y squared equals 10, and I'm going to substitute this x plus 2 in for y. So then what we have is x squared plus x plus 2 squared, whole thing squared, equal to 10. So we have x squared plus, now remember this is x plus 2 times x plus 2, and it equals 10. So x squared plus x and x, that's x squared, and then outer is 2x, inner is 2x, so we have 4x, and then 2 times 2 is 4, equaling 10. All right, so we have x squared and x squared would be 2x squared, 4x, and then subtracting the 10, we'd have negative 6 equals 0. So the nice thing here is that everything is divisible by 2. So I'm going to go ahead and simplify it just to make the possible factoring easier. I'm hoping you can factor, because that's the easiest way to solve a quadratic, in my opinion. So you have x squared plus 2x minus 3 equals 0. And then we can factor those two numbers that multiply to negative 3 and add to 2. That's a positive 3 and a negative 1. Set each of those equal to 0. And you get x equals negative 3, and you get x equals 1. Alright, so those are our two x values. So we have to find the y values that go with it. Actually, this point's perfect. I have it right. I have them intersecting at 1. Actually, I did a really good job over here at negative 3. So my 2 points look like they're pretty good. But I need to find the y values at those points. So I'm going to use y equals x plus 2 for that. So if y equals x plus 2, y equals negative 3 plus 2, this would be at y is negative 1. So the intersection would be at negative 3, negative 1. Which is that point right there. And then this other intersection, y equals x plus 2, plugging the 1 in for x, y equals 1 plus 2, so y is 3. So we have 1, 3. All right, and then number 17. We do that one as well. So we eliminated the variable when we did our substitution. We eliminated the y, solved for x, and then found the y that corresponds with each x. All right, so now I'm going to look at number 17. 17, we have x squared plus y squared equals 4. That's an equals. My pen just kind of dragged. And then we have y squared minus x equals 4. All right, we want to solve this system. So this is actually, this would be a circle with a radius of 2, center at 0, 0. This, you only have a y squared, you don't have an x squared, so that means it's actually a parabola. So we have a circle and a parabola. So they could potentially intersect 4 times, like even if I just drew like a generic representation without getting detailed about it. If that's our circle, and then actually this is it's y squared, not an x squared, so it's opening to the side. So we could potentially have 4 intersection points between the parabola and the circle. So we need to kind of look out for that. I picked this one because you can actually solve this one using elimination. Because the y squared, if you eliminated them, everything you would be left with would be x's. So the first thing I'm going to do is I'm going to flip these two to get the y's to line up. It's okay that we have an x squared lining up with an x. We'll deal with that. But make sure you keep your x negative, and then plus y squared equals 4. I do want the y squareds to eliminate. So I'm going to multiply one of my equations by negative 1. So we have x squared plus y squared equals 4. And then this will become a positive x, negative y squared equaling negative 4. So now I'm going to add those two together. The y squareds would cancel. Don't add these two. Well, I mean, you do, but you don't. You just write them side by side. You can't combine them. So x squared plus x equals, and actually these would cross out and become 0. So the nice thing is this is actually ready to factor. Just take an x out. Then you have x plus 1 equals 0. Set each of them equal to 0. So we have x is 0 and x is negative 1. So we're going to have to figure out the y values for each of these x's. So I'm going to use, it doesn't matter, I'm going to use x squared plus y squared equals 4 for both of them. This one I'll plug the 0 in. So 0 plus y squared equals 4, which means y squared is 4, square root both sides, y is plus or minus 2. So there's actually 2 intersection points there. We have one at 0, 2, and one at 0, negative 2. So there's 2 places it intersects. Over here, plugging the negative 1 in for our x squared, you have negative 1 squared plus y squared equals 4. So that's 1 plus y squared equaling 4. Y squared is 3. Square root both sides, so y equals plus or minus the square root of 3. So this x value, negative 1, has 2 y values that go with it. So this parabola did intersect the circle at 4 different places. And that's your answer. All right, and then finally number 38. I chose this one because it has a term that has both x and y in it. So for this one, we have 2 equations. We have 5xy plus 13y squared plus 36 equals 0. And then we have xy plus 7y squared equals 6. So for this one, I'm going to try to get rid of the whole xy term. So I'm going to multiply this second equation by negative 5. So first equation, we had 5xy plus 13y squared plus 36 is 0. So now this one, you have negative 5xy. We'll have negative 35y squared, and then equals negative 30. We can leave that like that, or we can actually move this 36 over. It doesn't matter. But now we can add those two together. I'm going to just deal with that 30 in a minute. So that'll cancel out. Negative 35 plus 13 is negative 22y squared. Plus 36 equals negative 30. So solving this, I'm going to move that 36 over. So you have negative 66. Divide both sides by negative 22. And y squared equals 3. So then you just square root both sides. So y equals plus or minus the square root of 3. Alright, so now we need to figure out what our x equals. If y is a positive or a negative square root of 3. I'm going to pick an equation. I'm going to pick the shorter one. I'm going to use xy plus 7y squared equals 6, plus it has just one x in it, which in the long run that'll make it easier. So for this one, I'm going to do y equals radical 3. This one, I'm going to do y equals negative radical 3. and I'm going to plug it in. So we'll have x radical 3, or x times radical 3, plus 7 times radical 3 squared equals 6. Alright, so more typically we write this radical 3x. Now this radical 3 squared would be just 3 because it takes the square root away. The square root and the squared cancel out. So we have 7 times 3, which is 21, equaling 6. Subtract 21 from both sides, so radical 3 times x equals negative 15. And divide both sides by radical 3, which we could rationalize so we don't have a radical in the denominator. If we multiply the top and the bottom by radical 3, then x equals negative 15 radical 3 all over 3, and 3 goes into 15 5 times. So x equals negative 5 radical 3. So the answer we get from that one is negative 5 radical 3 and radical 3. Not pretty answers, but it is what it is. Now over here I'm going to do the same thing. We're going to have some sign changes. So we have x times negative radical 3 over here, and then plus 7 times negative radical 3 squared equaling 6. So we have negative radical 3x. This would be 3, and then times 7 will be 21 equals 6. Subtract 21, so negative radical 3x equals negative 15. Divide by negative radical 3, so you have negative 15 over negative radical 3. I'm going to multiply the top and bottom by radical 3, just like I did over there. It will become positive 15 radical 3 all over 3, which is 5 radical 3. So our answer is 5 radical 3, negative radical 3. And that is it. So hopefully that will help you get through the problems in my math lab for 11.6. I will hopefully talk to you soon. Stay safe.